Welcome, guys. It's Mr. Aguilar here with the second part of our lesson of statistics, measuring of variation part 2. Yesterday or today, depending on what class you had, we did a study of what the mean absolute deviation tells us and how spread out our data is. And that's going to be helpful just to help us determine how far the data looks from the average mean. The other second part of that is to look at what's called the standard deviation and variance. This is what we mostly use in statistics, and it helps us do the same type of thing to see how spread out or how closely our information is to the mean. We're going to jump right into it, so here we go. The variance is a measure of how far the data set is spread out, the average of the squared differences from the mean. There's the formula. Sigma squared is equal to the sum of the sample minus the mean squared over the total amount of numbers. Again, we're going to go ahead and do this all together, so don't freak out that it is more difficult than what it looks like. I want to make sure that I have everything in line, and we are. The variance is represented by sigma squared, so that little sideways little angle right here. Not the angle, the sideways little mark here, if it's going to allow me to do this, is sigma, and it's used to show how far our set randoms numbers are from their average value. It's usually a number that's going to help us use to solve for the standard deviation. So you should be able to tell me the variance. That's going to be a number, and we're going to go ahead and use that to solve for the standard deviation. So here we go. The standard deviation here is the square root of the variance, and we're going to go ahead and use that today. Okay, standard deviation is a number that tells us how measurements for a group are spread out from the average mean or expected value. A low standard deviation, or low sigma, means that most of the numbers are very close to the average, meaning our graphs are going to be very close. The high standard deviation, or high sigma, or larger sigma, means that the numbers are more spread out. And what I want you guys to do a better job explaining what standard deviation does with the variance, is to go ahead and click on this little bit.ly, or type this into your web browser below. It would also be in the comments in the YouTube section. So please go and check this out. It's about a 3.5-minute video that describes what the variance does to our graph, how we're going to use it in order to do some more explanation. We'll cover the standard deviation next week and how we can use the standard deviation endpoints to tell us whether we're above or below the mean, whether it's likely average that we have our scores or whatever values we get from our data points, or whether we're above it or we're outliers. And we'll talk about those as well when we come back. To solve for the standard deviation and variance, we're going to find the mean of the data, meaning we're going to add up all the numbers, divide up by the number of parts that we have in our data. Then what we're going to do is we're going to add, for each of the numbers, we're going to take the mean and square the result. So we're going to take the sample number minus the mean squared, not the absolute value like we did yesterday. We're then going to work out the differences to solve for the variance. That's going to be the variance number. And then if we take the square root of the variance, it's going to give us a standard deviation, which is the one below. What I have here is the main problem that we're going to be focusing on, and I'm going to try to jump in on this to kind of go through this fast for you guys so we can kind of understand what the variance and standard deviation do. Just like with everything, the first thing we really want to be doing is put them in order if you want to. In this case, we don't need to for this data set. The first thing we want to be able to solve for is the mean. In this case, we solve this by adding up all the numbers together and dividing out by how many numbers we have. In this case, we have only 5 numbers. This makes up the total population of our data set, so you guys will be doing this as well. We have a total of 5 numbers. Negative 10 plus 0 is negative 10. Negative 10 plus 10 is 10. Plus 20 plus 30 divided by 5 gives me an average of 10. Okay, this is the mean value for this data set. If we do the one similar to the right, we're going to kind of do these simultaneously just because it makes sense for us, and we can describe the standard deviation and variance with our values. Adding these up, 8, 9, 10, 11, 12. We're going to get our values here. Adding them all together, we get a standard deviation of 50. Not standard deviation, mean, of 50 over 5, which is also 10. So we're going to look at both of these values as a mean. So if you were to graph these out on a number line, the average between the numbers that we have here on average is 10. Different set of numbers. Our range for this is kind of different, and let's just check out the range for our values. The range we talked about yesterday, doing the highest to lowest value. The highest being 30, the lowest value being negative 10. So we have 40 values in between them that makes our numbers more spread out. If we do the similar thing to the information to the right, to the data points to the right, you can clearly see that we have a much smaller range of values. 12 minus 8 is going to be 4. So the one problem to the left is more spread out data compared to the one to the right. So we should see our standard deviation much higher to the left than the right. Now, that's not going to always be the case, but we should be able to see that the numbers that we can range from are 40 numbers compared to only 4. And that's where we want to be able to see where the standard deviation comes into play. So let's calculate the standard deviation. In order for us to do that, we got to be able to calculate the variance. And what the variance comes from is using the numbers, subtracting them from the mean, and squaring them. And we're going to do that, and we're going to take the average of them, of all of them. And we're going to find the sum of them. So I'm missing that little e right here. And let's go ahead and do that. We're going to take our values. I'm going to try to make this smaller. We're going to take negative 10 minus our 40, because our 10 is our mean. And we're going to go ahead and square it. And we're going to do that to every single data point. 0 minus 10 squared plus 10 minus 10 squared. Again, this is slightly different than the mean absolute deviation. We're going to do 20. And we're going to do 30. 30 minus 10. Squared. Looking at all of our numbers here, we're going to take all of them and divide them up by 5. This is going to provide us the variance. So we're solving for the variance right now. And this is going to help us determine what the standard deviation will provide us. So looking at this, if we add up our numbers, we're going to get 400. So negative 20 is 20 squared is 400. Plus 100 plus 0. Negative 20 minus 10 is 10. 10 squared is 100. 30 minus 10 is 20. 20 squared is 400. And we're going to take those values and divide them out by 5 to get our variance. If you plug those into a calculator, we should get our values to be 1,000 over 5, which is going to be 1,000 over 5 is going to be 200. So the variance of the equation is going to be 200. This is going to help us solve for the standard deviation. So again, we expect the variance to be quite high because the numbers are more spread out on our range and on the number line from the data points. If we do the similar thing to the right, which we can do here, to get the variance, again, the variance is looking at all the numbers added together, subtracting them from the mean, and then squaring them. Doing the same points for these, we're going to do 8 minus the mean squared plus the next data point, which would be 9 minus the mean. Oh, well, minus 10, sorry. I'm going to go back on that. Looking at the wrong number. 10 squared plus 9 minus 10 squared plus 10 minus 10 squared. Again, taking all of our data points, subtracting them from the mean, and squaring them. Plus 11 minus should be a 0, 10 squared, and then plus 12 minus 10 squared. All over the total amount of numbers we have, which would be, again, 5. Looking at all of our values here, if you add them up on your calculator, we should get negative 8 minus 10 is 2, 2 squared is 4, 9 minus 10 is 1, 1 squared is 1, 10 minus 10 is 0, 0 squared is 0, 11 minus 10 is 1, 1 squared is 1, and then we also have the final one being 12 minus 10 is 2, 2 squared is 4, divided out by 5. Adding these numbers up, we're going to get 10 over 5 or 2. So quite significant difference from the one to the left. Our variance in this case is going to be equal to 2. So quite different than the spread to the right, from the left to the right, looking at two different data sets from our values. Now, the key thing when doing this is the variance only helps us describe the standard deviation. And one thing that we learned from above is that the standard deviation actually comes from the variance. Simply put, the standard deviation, if we had to calculate it, standard deviation is equal to the square root of the variance. And the square root of the variance, if we had to put it in symbol term, is simply sigma. So it's the square root of the variance here. So if we want to be able to do this to our number, we take our values, and all we really have to do, and I'll do this in a different color, if we take the square root of the variance, so sigma, or standard deviation, is equal to the square root of the variance. Our case, the variance happens to be 200. So square root of 200 happens to be 14.14. So the standard deviation, or sigma, is equal to 14.14. This tells me how spread out the points are from the mean, or from the average. It gives us a better indicator of where our numbers are going to be. And what we'll use this for next week is we'll find out, what does that 14 tell me using my average? What does that tell me? Am I going to be several standard deviations away from the mean? Am I going to be above it or below it? And we usually use a rule of 1, 2, and 3 standard deviations away from the mean, and we'll describe what that means. All I want you guys to be able to do today is calculate it. The one to the right here is, if we look at this, we're going to do the standard deviation again, is equal to the variance, the square root of the variance, which is the square root of 2. Square root of 2 happens to be 1.4. 1.41. So in this case, the standard deviation is 1.41. Again, looking at what the standard deviation tells us, it tells us how far away our points are from the mean. In this case, one standard deviation above the mean would mean that all points above 24.14 would make it over the one standard deviation above the mean, which again, we'll describe what that is for us. I don't want to get more confusing than that. But significantly, we have it two different sets. Even though the means are the same, the way the data points look are quite different. So variance is calculated by the sample minus the mean squared over the total amount. Standard deviation, we're going to take the square root of it to get the standard deviation. And that's all I want you guys to be able to do. Your problems today, okay, try this out, look this over, see where I got my values. Looking this over, the homework problem is to do this with this data points, is to be able to find the mean absolute deviation, find the variance, and find the standard deviation. I will go ahead, after you guys are done with this tomorrow, I will go ahead and send you a picture of the solutions via Schooloop and via Remind. So please keep up to these. Understand that on Friday you should have all your points for your data set for the project. Okay, so I'll post this along with the problems, and then we're going to finish up that last slab, which I believe is talking about the normal distribution, what the standard deviation tells us, and how we can use that with the mean to help us analyze our data. Okay, so you guys have a good night, a good day. You guys take care. All right, Aguilar out. Bye.